Hello folks and welcome to a brand new video of Mr. Pi. Can you find the area of the shaded portion? Pause the video and try for yourself in 3, 2, 1. We have a square A, B, C, D. And using base S triangle CD, we have a triangle EDC. And the length of A is 7, the length of C is equal to 3. Now first of all we will begin with a small construction, that is joining the line AC, which is the diagonal of the square ABCD. And if we assume that the side length of this square is A, then the length of this diagonal will be A root 2 by using the formula. Now let's assume this angle right here to be alpha. Okay, this angle is equal to 45 degree because the diagonal of a square bisects the angle which is 90 degree. So this angle right here is equal to 45 degrees. Now this is A. CD will also be equal to A because the side of the length of square is A. So if you use Pythagoras theorem in triangle CDE, we get the value of ED to be root of hypotenuse square minus base square, that is 9. Okay, now we'll use cosine law in triangle ACE. Okay, so using cosine law in triangle ACE, we get 7 square is equal to A root 2 whole square, that is A square 2A. 2A square, you can write directly 49 plus 3 square, that is 9, minus multiply of these two, that is 3a root 2 into 2, that is 6a root 2, and finally the angle of cos alpha plus 45 degree. So now what you can do is you can write 49 is equal to 2a square plus 9 minus 6a root 2 into, so cos alpha was 45 degree will be equal to 1 by root 2 multiplied by cos alpha minus sine alpha. Okay, so now we can cancel out root 2, so we get 40 is equal to 2a square minus 6a, 2a square minus 6a into cos alpha. So cos alpha will be equal to hypotenuse upon base, that is a by 3, and minus sin alpha equals to perpendicular by hypotenuse, that is root a square minus 9 upon 3. Sorry, yes, root a square minus 9 upon, I think I've done a small mistake, base upon hypotenuse, that is sorry 3 upon a, and minus perpendicular upon hypotenuse, that is root a square minus 9 upon a. Okay, so we can cancel out a, and we get 40 is equal to 2a square minus 6 3s are 18 minus 6 root a square minus 9. So we get again root a square minus 9. If we get 58 is equal to 2a square plus, sorry, so negative 6 into this will be plus 6 root over a square minus 9. Now if we take 2 common from each side, then we get, after taking 2 common, we get 29 is equal to a square plus 3 root over a square minus 9. Okay, now let's find the area of this A B C E A. Okay, ABCE will be have an area of this triangle in plus this triangle. So this triangle ABC will have an area of 1 by 2 a square plus this triangle will have an area of 1 by 2 AC into C, that is a root 2 into 3 into sine of the middle angle, that is sine 45 plus alpha. Okay, so we get 1 by 2 a square into plus 3 by 2 root 2 a, 3 by 2 root 2 a into sine 45 plus alpha. So sine 45 plus alpha will be sine 45 into cos alpha plus cos 45 into sin alpha. That is, we'll take common of both 45, that will be 1 by root 2. So we get 1 by root 2 sin alpha plus cos alpha. Okay, so we can cancel out root 2 root 2. So we will get 1 by 2 a square plus 3 by 2 a, and again sin alpha will be equal to root a square minus 9 upon a, and cos alpha will equal to 3 by a plus 3 by a 3 by, okay, so we can cancel out a, so we get a square plus 3 root over a square minus 9 plus 9 upon 2. Okay, so we have a square plus 3 a square minus 9, a square plus 3 a square minus 9 to be 29. So 29 plus 9 upon 2 is equal to 38 by 2. Therefore the area of required ABCE will be 38 by 2 equals to 19 square units. This is the required answer. I hope you liked it. This question was from algebra 1452, so do follow them on Instagram. This question is not simple but quite difficult. You have to use cosine law in this triangle. You have to know how to use the trigonometric ratios and the Pythagoras theorem that you everybody must know. You must correlate these two triangles and find the total area of the required quadrilateral. So thank you.